Electricity! We use it every day! But do you know how it works? Well, in this video, we're going to find out together. Let's go! Hey there! Welcome to my channel! You know what's awesome? Electricity. With just a flick of a switch, you can power your house with all of the lights, the TV, the computer. It makes life so much easier! But have you ever stopped to think about where electricity actually comes from or how it gets to your house? Well, let's find out together. First, we need to understand atoms. All matter is made up of atoms, the smallest building blocks of everything. Atoms are neutral, meaning they have no electrical charge. But inside the atom, there are positively charged protons, negatively charged electrons, and uncharged neutrons. The number of protons and electrons are usually equal, making the atom neutral. But sometimes an atom can gain or lose an electron. When it gains an electron, it becomes negatively charged, and if it loses an electron, it becomes positively charged. These charged atoms are called ions. Now, when certain materials are rubbed or pressed, like a balloon being rubbed with your hair, electrons can be knocked from one atom to another. If the receiving atom doesn't already have an opposite charge, it will become a negatively charged ion, and the atom that lost the electron will become a positively charged ion. These oppositely charged ions attract each other. And if the material is a good conductor, like metals, the flow of electrons continues, and we get an electric current. But we can't stop there. We need to answer a very important question. Why do some materials allow the flow of electrons while others don't? To answer that, we need to look at a material at the atomic level. Materials are made of many atoms close together. In an insulator, like rubber, the electrons in the outer shell of the atoms are tightly bound to their atoms and coene and move from one atom to another. However, in a conductor like copper, the outermost electrons are loosely bound and can move, so when you apply a voltage across copper, electrons flow easily from one atom to another and then to the next, creating a flow of electrical current. Now, you got it. You've just learned how electric current works. But wait, there's more. Electric current has two types: direct current and alternating current. In direct current, the electrons flow in only one direction. You can think of it like a one-way street. In alternating current, the electrons periodically change direction. Imagine those electrons taking turns flowing down a two-way street. Most of the electricity that comes to your house is alternating current. Okay, we've learned about electric current, but how do we use it to do things like light up a bulb or power a motor? Well, let's take a closer look. Electrical current can be used to do work when it flows through a device like a light bulb or a motor. A simple circuit consists of three parts: a power source, like a battery, a conductor, like a wire, and a load, like a light bulb. When you complete a circuit, the flow of electrons from the power source creates a magnetic field around the wires and the load. The magnetic field pushes and pulls on each other, creating a force. This force causes the coils inside the motor to spin, which powers the fan blades. And voila, you've just powered a motor with electricity. And what happens inside a light bulb? Well, when current flows through the filament, the resistance of the filament causes the electrons to bump into the atoms of the filament. These collisions cause the atoms to vibrate faster. Faster vibrations mean higher temperature. The filament gets so hot it glows, and voila, you've just lit up a bulb with electricity. So now you know how electricity works and how it powers our world. But remember, electricity can be dangerous. Never touch a live wire and always follow safety rules. Now go out there and be a scientist. Use electricity wisely and keep learning. Who knows? Maybe one day you'll invent something that will change the world.